Hello, we are Lieve, Tim, Stijn and Mark, and we are group 19. This week we researched the particulate matter concentration during cooking. Our research is inspired by a paper that stated that 90% of our exposure to particulate matter is indoors. We wanted to test to what extent the ventilation in the kitchen prevented dangerous concentrations in particulate matter. We tested this with a normal hamburger and a vegan hamburger. We are environmental scientists after all. Our test setup is a closed kitchen with one ventilation point, the range hood. You can see that the kitchen is a small closed area, a perfect closed box model. We place a particulate matter meter on face height to get the most accurate inhalation exposure concentrations. To test to what extent the ventilation of a kitchen prevented dangerous particle matter concentrations, we baked 2 burgers without the exhaust hood on and 2 burgers with exhaust hood on and on the highest ventilation rate. We repeated this with vegan burgers to see whether there was a difference in particulate matter concentration between vegan and meat burgers. Here you can see a time lapse of the burgers being baked. This is the measurement with the fume hood on. The concentrations of the particulate matter with a diameter between 0.5 and 2.5 micrometers starts to increase as soon as the butter starts to melt. You can see in the graph that the concentrations rise to around 250 microgram per cubic meter. Because we are no chefs, we sometimes burn our food. We were interested if this would have an impact on the PM2.5 concentrations in the kitchen. However, as you can see, there is no significant increase in the PM2.5 concentrations at the end of the measurement where the burgers got burned. From this observation, you can say that burning your food lightly does not release additional particulate matter. Here you can see the time lapse of the burger without the fume hood on. In the graphs, you can see that the Dylan 1700 had some difficulties measuring at high concentrations. At the places where the Dylan had difficulties, the concentrations dropped below zero. If you compare the graphs of the concentration of particulate matter from the burger with and without the fume hood, you can see that the fume hood makes a significant difference in concentration of particulate matter. The highest measurement of the burger with the fume hood on is around 250 micrograms per cubic meter. The measurement without the fume hood gave a maximum of around 300 micrograms per cubic meter. We estimated that the fume hood lowers the particulate matter concentration with 16.7%.
After the beef burgers, we did this experiment again, but this time with vegan burgers. We were curious what the difference between meat and a form of vegetables would be.
In both graphs it is visible that the PM concentrations build up more gradually than with the hamburgers. The peak value without the fume hood is 400 microgram per cubic meter, and with the fume hood on, it's 350, so that's a difference of 12.5%. When comparing the particulate matter graphs from the hamburger with the vegan burger, two things stand out. The first thing is that the particulate matter concentration from the hamburger rise immediately when baking the meat, where the vegan burger has a more gradual build-up. The second thing that stands out is that the highest particulate matter concentration peak is unfortunately measured when baking the vegan burger. The discussion. First of all, the concentrations that we found were surprisingly high. At least we did not expect these concentrations when looking at the European standard of 25 micrograms per cubic meter in a 24-hour mean. However, in literature with comparable experiments, matching data can be found. In a study done in Korea, they found out that frying causes an average of 425 micrograms PM2.5 per cubic meter. With this in our minds, the 350 micrograms per cubic meter is high, but certainly not impossible. Another remarkable point in their measurements are the sudden PM concentration drops in the graphs of the hamburger without extractor hooked on and in both the observations from the vegan burger. These observations are hard to explain, but we think it's due to the exceeding of the measuring range of the Dylos DC 1700. We tested this possibility by measuring the concentration when using deodorant, in which the measured values also suddenly disappeared after some time. This was only the case for the small particles, but the big particles could still be measured. So to get the particles in the size range of 0.5 to 2.5, the big particles needed to be subtracted from the small particles, leaving us with negative concentrations when the small particles were not measured. Another point of discussion is, when baking the vegan burger, it seemed to cause more pollution than when baking the hamburger. However, when analyzing all our data, it becomes clear this is only the case when we look at the PM size range of 0.5 to 2.5 micrometer. When the particles with a diameter bigger than 2.5 micrometer are included, the highest number densities can be found when baking the hamburger. In the graphs, we started our concentrations of PM2.5, which is levels of 300 microgram per cubic meter for the hamburger and 400 microgram per cubic meter for the vegan burger. These concentrations could be harmful to humans if they are exposed to it long enough. A research from the WHO states that concentrations above 300 microgram per cubic meter are classified as hazardous and could cause serious aggravation of heart or lung disease. When comparing the observed data with the PM2.5 concentrations in cities around the world, the lowest maximal value of 250 micrograms per cubic meter matches the daily concentrations in New Delhi, the most polluted city in the world. Conclusion: our kitchens are not as clean as we think they are. The invisible air pollution can reach concentrations as high as the most polluted city in the world, even when baking a vegan burger. To conclude, there is a difference, but a 16% difference is not sufficient for clean air, so a better extractor hood should be installed with a higher ventilation rate. However, more research is needed in which a measuring device with a higher measuring range should be used to research these high values and their validity. So in the end, if you want clean air and reduce your particulate matter exposure, you should either stop baking, get a really strong fume hood, or move to the cleanest place according to IQ, the Bahamas.